All right, guys, today what we're going to do is we're going to solve systems of equations. And this is something you have done before. Today we're going to just solve by graphing. There's 3 different ways to solve these. And today we're going to do by graphing. All right, so systems of equations, all that means is 2 or more linear equations. So 2 or more lines on a graph, that's all it means. And we have 3 different types of solutions. We have one solution, we have a no solutions, and we have infinite solutions. So one solution is just where we have 2 lines on a graph that intersect at one point. So the point that they intersect, that is our solution. And that's our, so that's a one solution. All right, a no solution, these are going to be lines that never touch. So if lines never touch, we call those parallel lines. So anytime lines are parallel or they have the same slope, then they're never going to cross, and those are no solutions. All right, and then we also have this weird answer of infinite solutions, where what happens is we have 2 equations, and when you solve for y, or when you get them in the correct form of an equation, they actually end up being the same line. So anytime you have 2 lines that end up being the same line, you get a no solution. All right, so the first thing I want to do is let's go ahead and solve each system of equations below by graphing and identify the solution. So what we're going to do, we're going to graph each one of these lines one at a time. Let's use black. I'm going to use black to graph the first line, and I'll use orange to graph the second line. And you don't have to use different colors. I'm just using that so you can see it visually. Okay, so when you graph a line, my black line, I'm going to first try and pick out my M and my B. So my black line, my slope of my black line is -5/3. And my B is -6. Okay, so you're always starting with your B. So we're going down to -6, and we're putting a dot. And then we're going to use our slope, rise over run. Okay, so my slope is -5 over +3. So I'm going down 1, 2, 3, 4. Oh, I'm going to go off 1 off the graph, and that's okay. I'm going down 5. 3 is positive, so I'm going right 3. 1, 2, 3. All right, I'm putting another dot. I can't go down into the right anymore, so I'm going back to my y-intercept, and I'm going to go up 5. 1, 2, 3, 4, 5, and I'm going to go to the left 3. 1, 2, 3. Notice how I went opposite of what I did the first time. So now I'm just going to grab a ruler, and I have rulers for you to use if you want to as well. And actually, I think I can make more points. So I'm going to keep going up 5. 1, 2, 3, 4, 5, and to the right 1, 2, 3. Up 1, 2, 3, 4, 5. 1, 2, 3. And you're just going to graph as many points that'll fit on your graph at a time. Then I'm going to use my ruler to make the line, and I have rulers that you guys can use as well. They're just sitting right behind my desk. If you want to grab one, feel free at any point. All right, so that is the first line. Now the second line, my slope is 1/6, and my B is +5. So I'm starting with my B, which is +5. We're going up to 5, and then we're using our slope 1/6. So we're rising 1, going to the right 6. 1, 2, or 1, 2, 3, 4, 5, 6. I can rise 1, but I can't go 6 anymore, so I have to go back to my y-intercept and do the opposite. So we'll go down 1 to the left 6. Let's count. 1, 2, 3, 4, 5, 6. Okay, I'm not going to be able to go down and left anymore, so I'm just going to go ahead and connect these dots. And our solution is where these 2 lines cross. Okay, so the solution of this set, and I'll go ahead and write the solution in red, but is this point right here. So the solution is a point on the graph, and you have to write your solution as an ordered pair because that's how you write points on a graph. So the point that it's at -1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4. So it's at -6, 4. And that is our solution, and that is our answer. Okay, your answer on these will always be an ordered pair. So now let's go through and let's look at the next, number 2, the next example. And I'm sorry these graphs copied so weird. But that's just our copy machines here at Writer. All right, so this number 2 is our next example. So line 1 is going to be black. The second line will be orange again. So we need to figure out our M and our B. Okay, so our M here is y equals 5. Ooh, that doesn't have a slope. So what the slope is here is 0, because it's a y equals line, and our y-intercept is 5. So we find a y-intercept of 5. So we find 5. And what a y equals line is it's just a horizontal line where y equals 5. So we can go ahead and draw that line using my ruler. If you don't use rulers, just do the best that you can. Make sure you have arrows on the end of your lines because lines never stop. All right, then we have to graph that second line. So we have to say, what is our slope? Well, our slope is 2. And what is our B or y-intercept? And our y-intercept is 7. Okay, so we always start with our y-intercept. So we're going to go up to 7 and we're going to put a dot. And then we're going to use our slope. Remember, slope is usually rise over run. So if you have a whole number, to make it a fraction, all you have to do is put it over 1. Because 2 divided by 1 is still 2. So now we use our slope. We'll go up 2 over 1. I can't go up 2 anymore, so I'll go back to my intercept and I'll go down 2 over 1, down 2 over 1, down 2 over 1, and you can keep going. At this point, though, I already see where it intersects, so I'm going to go ahead and use my ruler and connect the dots. Okay, make sure you put arrows at the end of your line. All right, and where it intersects is right here, and that looks like it's at -1 up to 5. So our answer for this question is -1, 5. All right, and this is how we solve systems by graphing. All right, we're going to do a couple more examples because some of these examples, now the first 2 have been in slope-intercept form, but if we look at the next one here, example number 3, those are not in slope-intercept form. So what you have to do before you can graph the line is put those equations in slope-intercept form, or in other words, solve for y. So I would kind of you're going to need some room here. I'm not sure there's enough room in your box, but kind of break up your paper so you can solve each equation for y. So the first thing that I'm going to do is solve the first one for y. So that would be 6x minus 5y equals -45. Notice how I'm writing small because I have to solve 2 equations, so I'm trying to give myself enough space in the box. So what we're going to do, we're going to use opposite operations and get y by itself. So we're going to say minus 6x because I want to move that 6x to the other side of the equal sign. All right, and what we're left with is this -5y equals -6x minus 45. All right, now we want the y by itself, so I have to divide by -5, divide by -5, and divide by -5, basically all the way across, and you get y equals -6 over -5 is positive, because a negative over a negative is positive, so 6 over 5, and then x, -45 divided by -5 is going to make that a +9. Okay, so this is our equation that we use to graph. So now we can tell what is our slope. Well, our slope here is 6 over 5. And what is our y-intercept? Well, our y-intercept is 9. Now we can go ahead and graph this first equation. So we're going to start with our y-intercept of 9. Okay, and this is where some people get kind of confused because you can't go up 6 and to the right 5, but your slope is positive, so that's where you want to go. But when you can't do it, go back to your y-intercept and just do the opposite. So you're going to go down 6, so 1, 2, 3, 4, 5, 6, and you're going to go to the left 5. 1, 2, 3, 4, 5. Okay, I think I can go one more time. 1, 2, 3, 4, 5, 6. To the left, 1, 2, 3, 4, 5. Okay, so we've drawn our first line. And something I want to show you that's really interesting about this was we couldn't go up and to the right, so we went down and to the left. But I want you to look right here. Before we made it positive, weren't they both negative? And if we go down 6, isn't that negative 6? And to the left 5, that's negative 5. You see how that makes a positive slope still? Okay, just kind of keep that in mind. All right, now I'm going to come over here, kind of split up my paper a little bit, because now I have to solve this second equation. All right, and we have to get y by itself. So I'm going to write maybe even a little bit smaller here. 2x plus 2y equals negative 4. Okay, and we have to solve and get y by itself. So we'll say minus 2x, and we get 2y equals negative 2x minus 4. Okay, we still want to get that y by itself, so we're going to divide everything by 2. All right, and you're left with y equals negative 2 divided by positive 2 is negative x. Negative 4 divided by positive 2 would be minus 2. So I always want you to tell me what your slope is. Our slope is negative 1. Remember, we like slope to be a fraction, so we can go ahead and put that over 1. And then our b is negative 2. All right, so we'll start with our b, our y-intercept at negative 2, and then we're going to use negative 1 to the right 1. So down 1, right 1. You're going to keep doing that until you can't do that anymore. And then you're going to go back to your intercept and you're going to do the opposite. So you'll go up 1, left 1, up 1, left 1. You're going to keep doing that until you can't do it anymore. Notice how I already see where it crosses. All right, and our intersection is the solution to systems when we're graphing. I like how I use orange and black with Halloween coming up. Ooh, I'm excited. Okay, so now we have to pick out our answer, which is the ordered pair. It's that point on the graph where those two lines cross, and that looks like it's at negative 5 up to 1, 2, 3. So the answer here would be negative 5, 3. Okay, let's look at one more example. Now some of these we're gonna on number 4, you don't have to solve that second one. You only have to solve the first one because the second one already has y by itself. You can graph that line already. So we're not gonna go over 4. Number 5. Also, if you look at that first equation, y is almost by itself already, so all you have to do is divide by 2. We're not going to do 5 either because I don't think we need it, but let's go ahead and look at 6. All right, so I'm looking at my first equation here, and I'm noticing that y is already almost by itself, but it has that negative in front of it, so I can't leave that just like that and graph it. We have to get rid of that negative. So if we have a negative y equals a negative x minus 6, we have to divide out that negative 1 to get rid of that negative y. So we're going to divide everything by negative 1, and you're going to get y equals negative x divided by negative 1 is positive x. Negative 6 divided by negative 1 is positive 6. All right, so now tell me what your m is. Well, it's 1. Let's go ahead and put it over 1, make it a fraction. And our b is 6. All right, so now we just need to graph this line. So we'll start with our b at 6, positive 6, and we're going to use our slope rise over run. So we're going to go up 1 to the right 1, up and to the right, up and to the right, and we're going to keep doing that until we can't anymore. And then we're going to go down into the left 1. I know these graphs are crappy, and I'm sorry about that. Just do the best you can. All right. Now we'll go ahead and connect those dots using my ruler to draw the line. Good. Make sure you have arrows on your line. And now let's go ahead and solve that second equation. So I'm going to just first write it out. So 3x plus 18 equals 3y. Oh, this is in a different order. So what I want to do to go ahead and start off with, I'm going to switch sides. I'm going to rewrite this. I'm basically going to just switch them around. I'm going to put the y on the left because that's how I'm used to seeing it. So this would be 3y equals 3x plus 18. And now I can solve this. I can just divide everything by 3. So divide by 3, divide by 3, divide by 3, and y equals 3x divided by 3 is x. 18 divided by 3 is plus 6. All right, at this point, we need to go ahead. So at this point, we need to go ahead and say what our m is. So our m is 1, or 1 over 1, and our b is 6. Now, are these numbers looking familiar to you at all? Do you see how this equation And this equation ended up being the same equation. So this is that funky no solution answer. If we were to graph this line, we would get every single point that we've already got. It would just be a line on top of a line. So this is where we have infinite solutions, or you can use the infinity sign. And you can write the word finite solutions. All right, so you can use just the infinity symbol. You don't have to write out the words. I just wanted to show you what that meant. So that's one of those weird solutions. All right, great job on that. Tomorrow we'll be talking about how to solve systems by substitution, which is more mathy. Okay, so today we're graphing lines. Tomorrow we're using algebra. See you later.